Okay, so let's look at coding challenge code find low and high index. So in this coding interview, I will give you two arguments. So we need to construct a function that accepts an array of integers and a target which is also an integer. It's not also, it's an integer, an array. And what we need to return is the low and the high index of the target. So in this case, we have a bunch of 2's, and what we need to return is the lowest index and the highest index. So in this case, what we would return is index 1, which is the lowest, and index 3, which is the highest. Now, if we have a target that is not 2, let's say that it's, I don't know, 5, we would return -1 and -1 because we haven't found the number. And if we have another example, if we have, let's say, 1, we would return 0 and 0 because we only have one integer that has index of 0, right? So you can take a moment and think about how you would solve this, try to code it up yourself, and then we can do it together. Cool, so let's do this. So we can have an array of 1, 2, 2, okay, 2, 2, 3. Let's also display our indices, like so. Cool. We'll have this function find low and high, which accepts array and a target. Our first case, we can search for 1, which will give us 0 and 0. Let's then search for 2, which will give us index 1 and index 3. Let's have a few examples, and let's have a 5, which will just bring us to -1, -1. I think this is enough for the first test. Yeah. Just for fun, let's implement brute force approach. So for brute force approach, we wouldn't use binary search. We would just iterate over each number. So let's do that for index and number. Enumerate A, which we can have is low and high, which additionally points to -1. We can do this here. And then if low equals to -1, we can say, okay, cool, low is, now if none equals to target, first we need to check, does it equal target? It does, cool. If low is equal to -1, low becomes integer, cool. But every time we also change the high pointer, and after we are done, we just return low and high pointers like so. Cool. Now if we run the code, we should see values 0, 0, 1, 3, -1, -1. Okay, cool. So this appears to be working. And if we try to describe BigO for this example, we could say, now because we are doing a linear scan, is like runtime is linear. We're actually checking each element inside the array, so n is the number of elements inside an array. And for space, we're not using any additional space, so it's constant, like this. Cool. So this is our brute force approach, but because we have information that our A is always sorted, we can use binary search. So we will build better, more optimal solution. So let's have low, which will have binary search low. We have A, target, low, which is 0, and high, which is last index. And this last index is just length A minus 1. So, okay, I just want to write the solution out. Now we can talk about it line by line. We have a last index variable that just holds up the pointer to the last index because we are using this multiple times here. And we have two helper functions, bslow and binary search high. And we actually return it at the end, right? So this function will have a binary search implemented. So this would improve our time-space complexity, or just time, because space in the brute force was of 1, and we probably cannot get better than that. Let's first implement binary search low. While low is less than or equal to high, we always on each iteration calculate mid point, which is low plus high minus low divided by 2. And if mid equals to target, it is. Like in normal binary search tree, we would return it, right? But here we need to have a results variable that will just update mid. Let's have results here that starts with -1 and it gets updated here, right? But we also need to move pointers. So if we want to go to the leftmost, we need to move high pointer to mid -1. Elif target is less than mid. We need to also move pointers like this. Else we move low pointer mid +1 like this. Cool. And the other function, which is a binary search high, it's exactly the same. Oh, we need to return. Yeah, of course we need to return a result. Come on. Okay, we need to return results at the end of each function here. Both functions are almost exactly the same. The thing that changes is that we need to move low pointer. Once we find our number, we need to move low pointer to the right. That's about it. So this looks good. And if we run the code, yeah, we should get expected results. And let's change, I don't know, this to 3. And we should get 4 at the end, and we do. Cool. So yeah, did we talk about time-space complexity? I don't think so. We can do that. Now we're doing 2 binary searches, so 2 log n, and in big O we can remove constants, so the time it's logarithmic, and for space it's constant. We're not using any additional space. We just have few pointers, and that's it. Yeah, I hope that helped. Yeah, till next time.